Okay, Algebra 2, we're going to start Section 5 from Chapter 4 today on completing the square. We're only going to get about halfway through, and then for your assignment, you're going to work problems like the examples I do today. And then tomorrow, we're going to finish the notes, and you'll have some more problems to work for homework then. So in the end, this homework assignment won't be due until Thursday, but it's in 2 parts, so don't wait till the last minute to do it. So today, we're going to be looking at completing the square. So previously, to solve a trinomial, you factored the trinomial on the left-hand side that was set equal to 0. Once you've solved the factored portions, then you knew the solutions to that trinomial. Today we're going to be looking at how to solve those quadratic equations using the square root property, and then tomorrow we'll actually be using the completing the square method. Okay, so example 1 says to solve this equation by using the square root property. So in the past, we probably would have moved the 64 to the left-hand side with the other number, then see if we could factor, set each factor equal to 0. That doesn't always work every time because not every problem is going to factor completely. So today we're going to use the square root property. So what I'm going to do is I'm going to look at the left-hand side of the equation, x squared plus 14x plus 49, and this is going to be a perfect square trinomial. And what that means by perfect square trinomial is if I factor this trinomial, then whatever is in the parentheses is going to be the same for both sets of parentheses, and I can actually write it as one set of parentheses squared is equal to the right-hand side. So what we're going to do is we're going to factor the left-hand side, same as we would have always done. So I like to start with x squared, and we want to know what two things multiply to get x squared. Well, that's going to be x and x. Then we need two numbers that multiply to get 49, but add or subtract to get the 14 in the middle. So two numbers that add to get 40 or multiply to get 49 and add or subtract to get 14. Well, since these are perfect squares, then the number should come really easy to you, and it's going to be plus 7 plus 7. So remember what I said is what's in parentheses is going to be the same for both parentheses. So the number that you come up with times itself should equal the last number, and plus itself should equal the middle number. So instead of me writing it twice, x plus 7 times x plus 7, I can write it as x plus 7 all squared equals 64. Okay, once we have a perfect square set equal to a number, I can get rid of the square by using the square root property. I can take the square root of both sides of the equation. So on the left-hand side, when you take the square root of a square, those are going to cancel each other out, and we're left with x plus 7 on the left. Now on the right-hand side, remember anytime you take the square root of a number, it's always going to be the positive and negative square root of that number. And I know that the square root of 64 is 8, so this is plus or minus 8. So now what we're going to do is we're going to solve two equations. I want to solve x plus 7 is equal to positive 8, and I want to solve x plus 7 is equal to negative 8. We're going to get two numbers, and then those two numbers will be our solutions for this problem. So the first equation, x plus 7 equals 8, so when I subtract 7 from 8, x is going to equal 1. The other equation, when you subtract 7 from negative 8, x is going to equal negative 15. Okay, so these are my solutions, x equals 1 and x equals negative 15. You always want to go back and double check, plug them into your equation and see if they work. Alright, so example 2, x squared minus 4x plus 4 equals 13. We're going to do the same process. So I want to look at the left-hand side of my equation, and I want to factor it. And I'm going to leave that set equal to 13. So what I need to know is, first we're going to start with x and x, and then I need a number that will multiply to get 4 and add or subtract to get negative 4. So in this case, negative 2 times negative 2 is equal to positive 4. Negative 2 plus negative 2 is equal to negative 4. So again, what's in parentheses should be the same, so that you can write it as a perfect square. X minus 2 all squared equals 13. Okay, since we want to get rid of the square, we're going to take the square root on both sides of the equation. So on the left-hand side, the square and the square root will cancel. X minus 2 equals the positive and negative square root of 13. Well, I know that 13 is a prime number, so the square root of 13 is not going to simplify. Okay, so we're going to continue solving this problem. Since I can't simplify the square root of 13, we're going to leave that in the problem. And I'm going to write this as one answer instead of two. So we know that we would need to add 2 to both sides of the equation. This would be x equals plus or minus the square root of 13 plus 2. So some people might write it this way and might say 2 plus or minus the square root of 13. So this would be the exact answer. You could type this in the calculator and find out approximately what those two answers are, but we like to leave them in exact form. Okay, so this will be part 2 of the 4.5 video on completing the square. Now we're going to look at how to complete the square to solve a problem involving a trinomial. So here's the key concept. It says to complete the square for any quadratic expression in the form a squared or x squared plus bx, use the following steps. Find 1/2 of b, which is the same as dividing by 2, and then square the result in step 1. So I always think of taking the b, divide by 2, and then square it. Whatever that number is, we're going to add that to the end of our equation, and that turns the number into a perfect square trinomial. Okay, so let's look at a couple of examples. So on this example, we're just trying to find c, which is the perfect square number, and write it as a perfect square trinomial. So whatever number is in front of the x, in this case it's a 12, we're always going to take that number, divide it by 2, and then square it. So I know that 12 divided by 2 is 6, and then 6 squared is 36. So in this case, when I write x squared plus 12x plus 36, I completed the square by adding the 36 to the end of the problem. This makes it a perfect square trinomial. Like the problems that we were doing the day before, 36 is a number times itself, and that same number added to itself will equal the 12 in the middle. So this is called completing the square, when you take the number in front of x, divide by 2, and square it. Okay, so let's check our progress. Same thing here. This says find the value of c that makes x squared plus 6x plus c a perfect square trinomial. So, like I said previously, whatever number is in front of x, in this case it's a 6, we're going to take 6, divide by 2, and then square it. So I know 6 divided by 2 is 3, and 3 squared is 9. So 9 is the c that will complete the square. It would be x squared plus 6x plus 9 is the perfect square trinomial. If I was to write it as a perfect square, it would be x plus 3 all squared. Whatever the number was before you squared it is what would go inside the parentheses. If I FOILed out x plus 3 times x plus 3, that would get you x squared plus 6x plus 9. So in this case, the answer choice is A. 9 is the number that completes the square to make the perfect square trinomial. X plus 3 all squared is the perfect square. So now that we know how to find the perfect square to complete the trinomial, we're going to use this to solve the equation by using this completing the square method. So the first thing we want to do is any constant term that's on the left-hand side, we're going to move it to the right-hand side. So this becomes x squared plus 4x equals a positive 12 now. Okay, so what I want to do is I'm going to rewrite that trinomial, and it's a binomial technically, but I'm going to leave a blank for the number that I'm going to add on the left-hand side. And because I am going to add a number on the left-hand side, in order to balance your equation, you have to add it on the right-hand side also. So remember, we just learned how to complete the square. The number in front of x, you're going to divide by 2 and square it. This is the number that's going to go in your blank on both sides of the equation. So 4 divided by 2 is 2, and 2 squared is 4. So I'm going to add 4 to both sides of the equation. Okay, I don't need this anymore, so I'm going to erase so I have plenty of room. So now on the left-hand side, because this is a perfect square trinomial, I can write this as x plus 2 all squared. The 2 comes from the number before you square it. So whatever your number is in the middle divided by 2, that's what goes in this set of parentheses. And then equals, on the right-hand side, 12 plus 4 is going to equal 16. So now what we're going to do is solve the problem like we did the day before, and we're going to take the square root of both sides. So when I take the square root of both sides, on the left-hand side I'm going to have x plus 2 equals. On the right-hand side, when I take the square root of 16, that's going to be the positive and negative square root of 16, which will be plus or minus 4. And remember, we're going to have two answers here. So I'm going to take x plus 2 equal to positive 4 and solve, and then x plus 2 equal to negative 4 and solve. So for the first equation, when I subtract 2 from 4, x is going to equal 2. And for the second equation, when I subtract 2 from negative 4, x is going to equal negative 6. Okay, we've got one more example here on completing the square. This time notice that the coefficient of x squared is not equal to 1, and we have a 3x squared minus 2x minus 1 equals 0. So the first thing that we're going to do is get rid of the 3 that is being multiplied times x squared. In order to get rid of that, we have to divide every term by 3 in the equation to make it an equivalent equation. So now we're going to have x squared minus 2/3 x minus 1/3 equals, and 0 divided by 3 will still be 0. Now I know we get afraid of fractions. We're going to be okay though. We'll work through it. So same as the last problem, whatever your constant is, you need to move it to the other side. So I'm going to take my negative 1/3 and move it to the other side. When it moves over, remember it becomes positive. So this is going to be x squared minus 2/3 x, and I'm going to leave a blank, equals 1/3, since I moved my 1/3 over, and I'm going to put another blank. Okay, so now we're going to complete the square. So remember, whatever number is in front of x, we're going to take negative 2/3, we're going to divide it by 2, and then we're going to square it. Okay, so you can use your calculator if you need to. Make sure you put it in parentheses. I'm going to go step at a time, and I know that when I do negative 2/3 divided by 2, that's going to be negative 1/3. And then when I square a negative 1/3, that's going to become positive 1/9. So use your calculator if you need to, if you're not sure about it. I'm going to be adding 1/9 to both sides of the equation. Remember, whatever you do to one side, you have to do to the other side. So that's why the 1/9 is on the right side as well. Okay, so now this is x minus 2/3, x squared minus 2/3 x plus 1/9 equals, on the right hand side I'm going to do 1/9 plus 1/3, and remember to change it back to a fraction, don't put decimals. So this is going to be 4/9. Okay, so now we're going to we already completed the square. We're going to write what is on the left-hand side as a perfect square trinomial. So remember, you're going to put a parentheses and a squared on the outside. We're going to start with x. The number that goes in parentheses is always the number before you squared it. So when I just did negative 2/3 divided by 2, that was minus 1/3. So that's what goes in the parentheses. Equals 4/9. Okay, so now I'm going to need to take the square root of both sides to get rid of my square. And I've run out of room, so I'm going to go to a new slide here. See if I can remember the equation. So x minus 1/3 all squared equaled 4/9. We already took the square root of both sides. So on the left-hand side, I'm going to be left with x minus 1/3 equals. On the right-hand side, we're taking the square root, so it's plus or minus the square root of 4/9. When you're taking the square root of a fraction, remember you take the square root of the top and the bottom separately. So the square root of 4 is 2, and the square root of 9 is 3. Okay, so now I have two equations to solve. I'm going to do x minus 1/3 equals a positive 2/3, and then x minus 1/3 equals a negative 2/3. So I need to add 1/3 to both sides on both equations. So again, use your calculator if you're scared about the fractions. But I know that 2/3 plus 1/3 is 3/3, which is equal to 1. And on the other equation, when I add 1/3 to a negative 2/3, that's going to be negative 1/3. So my solutions for this are 1 and negative 1/3. Okay, I thought that was the last example, but it's not. X squared plus 4x plus 11 equals 0. This one it says we're going to have an imaginary solution. So we kind of know something's going to happen at the end that's a little different than the previous problems. I'm going to start the same way though. Remember, move your constant to the other side. So this will be x squared plus 4x equals negative 11. Okay, I need to complete the square on both sides. So x squared plus 4x, I'm going to leave a blank, equals negative 11, and I'm going to leave a blank. I said complete the square on both sides, but we're only doing it on one side. Okay, on the left, we're going to take the number that is in front of the x, which is 4. You're always going to divide by 2 and then square it. That's the number that goes in the blank on both sides. So 4 divided by 2 and squared is plus 4. So I'm going to erase this so I have room. So on the left-hand side, I have x squared plus 4x plus 4. This is a perfect square trinomial. On the right-hand side, negative 11 plus 4. It's going to be negative 7. So since this is a perfect square trinomial on the left, it's going to factor into a perfect square. It's always going to be an x. The number that goes in parentheses is always the number before you squared it. So 4 divided by 2 was 2. Okay, equals negative 7. So now we're going to take the square root of both sides. So on the left-hand side, I have x plus 2 equals. On the right-hand side, I'm going to have plus or minus the square root of negative 7. So here's the imaginary part of this problem. We have the square root of a negative number. Okay, so if I'm going to write my answer as an exact answer, we need to simplify that radical first, and then we'll move the 2 over. So I'm going to write x plus 2 equals plus or minus. Now remember, a negative underneath the radical is the same as I on the outside. And I know that 7 cannot be simplified, so I'm just going to write this as I times the square root of 7. Or you could put square root of 7 and then the I. I don't like to put the I at the end because it looks like it's underneath the radical. Okay, then we would subtract 2 on both sides. So then x is going to equal, I'm going to go ahead and put my negative 2 first since it's the real number portion, and then plus or minus I times the square root of 7. So this is 2 solutions that works for this. They just happen to be imaginary solutions.